Well, we're all the way up to Module 6 in our Querying with Transact SQL course. So far we've covered the select statement, selecting from single tables, selecting from multiple tables using joins, using unions to get the results of two queries put together into a single row set. And in the previous module, we looked at using functions to get additional information from the values in our databases, and then aggregating those functions and grouping the rows that are returned in the result set. So we're already building reasonably sophisticated queries. What we're going to look at in this module is using subqueries and a special SQL operator called the apply operator. And what we're going to do here is see how we can take those queries we're writing and have queries within queries, which sounds a little bit meta. So Jeff, can you tell us a little bit about what we're going to cover?
Indeed, we'll have a look at subqueries and we'll talk about them in general context, and then we'll have a look at scalar subqueries where we're going to look at single values, and multi-valued subqueries where we're looking at lots of values. And then we also have a self-contained or typical subquery, if you like, and a special type called a correlated subquery. And then going on to that, another way of dealing with that information is using the apply operator with table value functions to return similar output.
Sounds good.
So to start off with, they're queries within queries. So we get a single query, select list as normal. So highlighted down here, we've got a select query, and that then returns its results to a calling query. So that could be a set of multiple different values. It could be a single value. We have different types. So results are passed to the outer query. You can test them, a typical one, a non-correlated one, you can test it, you can run that subquery, it should work, and then you can try it on the outer query, or you can even actually take the results of that subquery and see, well, actually, if I just type them in, does it work on the outer query? So we've got the results of the inner query, and we want to have a look at what sort of results they will be. They could be a single value. So in here, I've got select maximum order ID as last order from sales order. So we're looking at the maximum order ID, one single value. We're then passing that to the calling query and comparing the values in that outer query with the results of that subquery.
This is like a scalar function that we talked about previously.
Exactly. We're basically using this almost as a function. We're just saying, okay, I want to find a function which finds me the maximum value in the order table of order ID, and just using that as a result, single result. So I could actually run that subquery, say, oh, actually what I return is 979, and then as a test say, well, what happens if I put where order ID equals 979? We'll get exactly the same results. So it's entirely encapsulated in brackets and just generates that value, compares that value with the outer query.
And as it says there, I can use it anywhere that I would use a function, basically.
Completely. You can just, that bracketed part there, you can actually drop it literally anywhere. You could put it into a select list even. You can put it anywhere you want. Once it's in brackets, it just treats that as an individual unit. Now the multi-value one, though, a little bit different, because here we're getting multiple different entries returned. So I've got a query there that returns every customer ID for anyone with a country region of Mexico. So that's going to be a long list of entries in there. So I can't just say is something equal to this. But remember when we had that that ability to search for multiple values, and rather than using ORs, we used an in and then a bracketed list. Essentially, my bracketed list now is the results of this query.
Right.
So it can supply a list of values, and this one obviously I couldn't use in other places necessarily because I'm returning multiple values.
So you could think of this, I mean, I guess what we're saying is a multivariate subquery is returning, you could think of it as being a table that has one column. Exactly, so if you're coming from a database developer background, that's a way of thinking it. It's a row set with one column and a value in each row.
And it has to be that way round. You can't say, well, could I use it on one row with multiple columns?
Right.
No, it's one column with multiple rows.
And actually, if you're a developer and you're attending this course because you're already building applications in C#, we're really talking here about the equivalent of a one-dimensional array. Mm-hmm. It's an array of values that's coming back. Right.
It's essentially just a list of values returned to that. And I'm not looking for values that are in that list.
Okay, so I see.
So we're going to start with a scalar subquery. Here we're going to build this by stages. So I've got, firstly, the maximum unit price. So what is the maximum unit price in the sales order detail table? 1467.01. So then we can say, well, what would be the results if I actually type that value in? So let's have a look of products who have a list price greater than that maximum unit price from sales order details. So then we can search for that, and that will find me any products who've got that list price. And then I can then say, okay, well, rather than typing in, it's obviously not a very scalable solution to have people typing things in for different values, I would like it to work whenever. So instead of typing that value in, I just replace that with the query in brackets. So we've got a query which generated the value. We drop that in where the value was in.
So what we're saying then really is bring me back all the details of the products table for any product that has a list price that's higher than whatever the maximum price of something we've ever sold is.
Yes,
Right.
So it's going off and having a look at, essentially we're saying, are we overcharging for some of our products? So we've gone out and found the maximum unit price from sales order detail. That's the maximum we've sold things from. What have we got that's more expensive than that? And you'll see if I run this one, then we get the same number of rows, exactly the same rows. So essentially you can use that step-by-step process to build up a typical non-correlated subquery. You can say, okay, let's run the subquery part, that works, right? Just take its value, use its value in the outer query. Does that work? Well, yeah, that works.
So I'm effectively replacing a function just with some inline SQL that does the same job as a scalar function. It returns a single value that I then use in the outer query.
Yeah. We're going to have a look now about whether something is self-contained or correlated. Now, that's a very distinct thing. So a query that we've talked about so far is a self-contained query. So the subquery portion can be run and it works, and then it supplies its value to the calling outer query. And you can run them independently. So I can run a value and then we can test it. Now this correlated idea is slightly different. So what we're going to do, if we have a look at the subquery portion of this, we've got select maximum order date from sales orders as O2, that's fine. Then we've got where O2 MPID equals O1 MPID. Well, O1 MPID doesn't exist within that query. So it's going to go to the outer query, where you'll see that O1 does exist, get the employee ID value from there and use that. So essentially what happens is, for each row in the outer query, return me an employee ID and run the subquery using that value. And then go backwards. Logically, you're going backwards and forwards each time. So for each row of the outer query, supply the value, run the subquery, then do the comparison with the outer query, then go to the next row. Do it again, backwards and forwards each time.
I presume because SQL Server is set-based, that's not actually how it executes it.
It's not. However, they do tend to be quite intensive in your resources. So they're not the highest before. It's something you think, oh well, you wouldn't think I'll do a correlated subquery just because I can. There's a logical backwards and forwards process. Actually, SQL Server has amazing optimization abilities and actually doesn't do quite anything that complex. But
Right, I see. Okay.
their logic, and also the logic of them as well. I think whenever you see one, when you get to understand them quite well, you can work out what it does, but it takes a bit of thought to think, okay, what is that actually doing in there? I have to have a look at that and see what's going on. So logically, I wouldn't use them just because you think, oh, well, nowadays they're not as slow as they used to be. It's something that is a bit slower and it's logically quite complex, but it can do something that's quite complicated, because what I'm looking for here is for each employee ID, show me the values where the order date is equal to the maximum order date for that employee.
So the last order that employee took in English is what we're saying, yeah. Okay.
Okay, now I've got a list in here where we're going to start off with a simple query. So I've got order ID, sales order ID, order date, and it's just going to do an order by there. So there's nothing complex about this at all. Then to take that a step further, we're going to see, actually, I'm interested only where the order date is the same as the maximum order date for everyone from the sales order table. So we're just doing that for absolutely everyone. So I'm only interested in where it's equal to the absolute maximum grand total. But that's not what I'm interested in, really. What I want to do is find the totals for each customer ID. So we're going to go through here, and now my subquery has got this clause where it's saying where SO2 customer ID equals SO1 customer ID. Now, SO2 is defined within that query, so that's fine. SO1 it won't find, so it's going to look to the calling query and say, okay, I need the customer ID from there. So for each customer ID you have in there, give me the maximum order date. So now we're looking at by customer, not the grand total. For each individual customer, give me the value. So I've got the customer ID, then I've got the value which has got the maximum order date there for that customer, one row per customer. So it's returning those values from the inner query to the calling query, backwards and forwards, because we've got a value in there that doesn't exist in the subquery. Probably the most complex thing in here is that they can't be tested. So if you run it, it doesn't work. It's quite difficult. You can't do that step-by-step process of saying, well, let's try the subquery. Does it work? Well, no, it doesn't.
Because there's a dependency on the outer query.
Exactly. So it's not a query where we've said you can build ones up. This one you can't. You're basically starting from here. This is my first point that I can start with. So it's already reasonably complex in there.
Okay.
Now we've talked about correlated subqueries. There is a technique we can use with an apply operator and a table valued function, which can get us, it can do a number of things actually, but one of the things it can do is get us a very similar result in maybe a less complex piece of code. You can use it to do something which is essentially like a join as well, but here we're going to use it to do something we can't do with joins that we could only achieve with a correlated subquery, and that's using a cross-apply operator, and we're going to pass a value into a function. Now this function is a function that returns tables. So s.supplierID does not exist within a function. It won't know what it is. So it's going to again say, well, where do I get that from? Oh, it comes from the calling query. And s is suppliers, so it goes, okay, that's suppliers.supplierID. I can see that. I'll get that, I'll run on that value. Then I'll return the value to the calling query. Then I'll go to the next line and we'll run it in that way. In the same way the correlated subquery, backwards and forwards, run it for the next supplier ID in there.
So conceptually the cross-apply then is running the function for each row with a value that we're getting for each row.
Yes.
Okay.
Yeah. So each individual supplier ID, it will go to another value to run it again, another value, run it again in there. Now we also have an outer apply, so as well as a cross apply we can use outer apply, and then what we have is extra values for the right table. So if you take a left and a right join, in here we're going to basically say what we want is a left join, a left outer join. I want nulls in that right table because they don't exist, because I don't have any values for that supplier ID. I would like to.
The right table in this case being the table that's returned by the function.
By the function, yeah. Right. The P table in this case. Yeah. So it would be P.product ID, product name, unit price. Those values would be null where we don't have matching records in the same way we would with an outer join. What we have here then is a function which is UDF max unit price. We can run that against any sales order ID and it will go out and it will find from sales order detail the maximum unit price for that sales order ID from the sales order detail table.
Okay.
But I'm running it on soh.salesorderid.
Well, before we do that, I know in this course we're not covering how to create functions or design functions, but can we at least see the definition of that function so we get an idea for what's being returned by it?
I'm glad you mentioned that because I already have that in another...
Already up my sleeve.
Another one here. We have SP help text. So what we can do with this is get it to return the syntax of that function.
Oh, okay, so let's have a look at that.
Now, as you said, we're not actually using this to create functions at the moment, but we can certainly see that it returns the sales order ID, the maximum unit price, and it's going to get that where the sales order ID is equal to @sales order ID. So that's actually a variable that's being passed
into it.
So we're passing it that value, sales order ID. and from that it's going to return the max unit price.
Okay.
So it's quite straightforward, to be honest. It's
Just the most expensive item in the order gets passed back out.
Yeah, exactly. And it's doing that from sales order detail, where in the cross apply you'll see we're actually looking at sales order header. So we're saying for values in sales order header, go and look at the sales order ID and find me the maximum unit price.
Right, so we're
that
saving
sales
ourselves a
ID.
more complex join here where we're joining to another table.
Yes.
Right.
So yeah, you'd have to join them together, and also we'd have to aggregate values because we're going to have to look at the maximum. And you say, well, that's not quite right because the maximum sales is not what I want. I want it for each individual order header.
Yeah.
So that's where we're back to correlated subqueries again. And this is an alternative way. We could do this with a correlated subquery, but we can also do it using this approach. Again, you are still having that idea of passing things from the calling query to the, essentially it's not a subquery, but passing it to the function which is acting as subquery in this case.
Okay.
So there's some concepts that are quite similar, but a lot of people think this is conceptually more straightforward and certainly easier to read. And you think, okay, I can see, assuming you understand what the function does, I can understand that. I think, okay,
If you effectively think of it as being I'm running that function for each row that the query returns.
Absolutely, yeah. So if we execute this, we should get the same sort of results. And there we go. There's for each sales order ID the maximum unit price. It's the same results that we would get using a correlated subquery.
Okay.
So we've had a look at subqueries, so queries within queries. Remember that when we start, we talked about scalar, multi-valued, but self-contained subqueries. And the key thing I would say is that the vast majority of subqueries are not correlated, so that you can test them as self-contained queries. So you can try them out, that works, that returns these results. From that, I can then craft an outer query which uses those results. So it's much more easy to test. There are cases where that's not possible, so then we'll have a look at self-contained versus correlated, and you may need a correlated subquery. You may need to use an apply with a table value function. But the majority of them are probably going to be those self-contained ones. All
right, fantastic. Well, thanks. That's a really good introduction to subqueries and to the apply operator. To take that a little bit further and experiment a little bit on your own, as always in this course, there's a lab that you can have a go at. So if you haven't already done so, download the lab files, set up your environment using Azure SQL Database and the AdventureWorks LT database, and have a go at the lab and try some of this for yourself. And then when you've had a go at that, come back and join us for the next module in this course on TransactSQL querying.